Today I am Roden Bernardo from BSECE, and in this video I will demonstrate the application of stepper motor using the Arduino Uno microcontroller. So the objective in this video is to demonstrate the stepper motor with ULN2003 motor driver application using microcontroller. So the materials that I used in this video are step motor 28BYJ48 with ULN2003 driver, the male-female jumping wires, Arduino Uno microcontroller, the USB data cable for Arduino, and the power supply, which is the 9 volts battery. This is the schematic diagram for the interfacing the step motor to the Arduino. So in this schematic diagram, I use the H bridge driver. So the output and input of the H bridge driver is connected to the Arduino. So the input 1 is connected to pin 8, the input 2 to pin 9, input 3 to pin 10, the input 4 to pin 11, and the power and the ground or the 5 volts pin and the ground pin is connected to the 9 volts battery. But in my actual presentation, I connected the step motor directly to the Arduino, 5 volts pin and ground pin. So in my actual presentation of the step motor, I used the ULN2003 driver, but the ULN2003 driver is not present in the filter tab, so I used the H-bridge driver. So this is the source code for exercise number 1. So first I define the pins that I used in the Arduino. So the pins that I used are pin 8, 9, 10, and 11, and it is defined as pin A, pin B, pin C, pin D, and pin D. So I also define the step delay, which is equals to E. On the void setup, I define the output pins, such as pin A, pin B, pin C, and pin D. On the void loop, I define the output pins which will receive the high signal or the low signal. And I also define the delay, which is the step delay, which is also equals to T. And this source code will be uploaded in the Arduino Uno. And this is the output for exercise number 1. So this is the source code for exercise number 2. As you can see, it is slightly the same with the source code of exercise number 1. I just modified the pulse which I sent to the stator. So in this source code for the void loop, I send the high pulse to the pin A and pin B on the first step. And on the second step, I send the high pulse to pin B and pin C. And for the third step, it is on pin C and pin D. And on the fourth step, it is on pin A and pin D. I just upload the program for exercise number 2 to the Arduino. And we will see the output on the step motor. This is the source code for exercise number 3. So the first thing that I did is to include the library, which is the stepper.h. Then define the constant float, which is the steps per rev, which is equals to 32. The constant float gear underscore rev, which is equals to 64. And the steps per revolution, which is the steps per rev multiplied to the gear rev. So the steps per out rev is equals to 2048. So it is 32 times 64, which is equals to 2048. And I define the variable, which is the int, which is the steps required. And the pins is arranged as 8, 10, 9, and 11. So for the void setup, I define the speed of the stepper motor, which is equals to 1, and the steps required equals to 4, and the step of the stepper motor is equivalent to the variable, which is the steps required, and this has a delay of 1000 milliseconds or 1 second. Next is I define the steps required, which is equivalent to negative steps per out rev over 4. So it is on the counterclockwise direction and rotates with a 90 degrees angle. So the speed is 1000 milliseconds and the step is equivalent to the step required. Steps required which is equals to 4. And it has a delay of 1000 milliseconds. So for the next rotation, I define the steps per out rev. So this is in the clockwise direction. So steps per out rev over 2 is equivalent to 180 degrees rotation. And the speed is 1000 and the steps required is equals to 4 with a delay of 1000 milliseconds. So for the next rotation, it is negative steps per out rev over 1.333. So it is in counterclockwise direction and it will rotate on 270 degrees angle and it has a speed of 1000 and the steps required which is or this step which is equivalent to 4 which is the steps required and it has a delay of 1000 milliseconds. So for the next rotation, it is steps per out rev over 2. So it will rotate in the clockwise direction with angle of 180 degrees and it has a speed of 1000 and the step which is 3 and the delay of 1000 milliseconds. So for the void loop, I didn't put a code because I was required to only show the one step or one operation of this whole code without me looping the process. So I just upload the code for the exercise number 3 on the Arduino and we will see the operation of this code on the stepper motor.